and this has to do with the idea of feeling of knowing. So maybe you don't know something, but do we actually have a mechanism in our minds that will allow us to know that we're close to a solution, even if we don't really know what the actual solution is? So it's almost like that tip of the tongue phenomenon when you can't think of a word, but you know the word. It's just not coming to you. We're going to see research done on feeling of knowing. And so this is work that was done years ago by Janet Metcalf. Actually, she did it here at Indiana University. And she gave subjects difficult problems to solve. Right? So these are intentionally difficult, so the problem isn't immediately aware. Most psychology experiments have these difficult problems to solve. So she gave subjects difficult problems to solve and then asked them to indicate in certain intervals how close do they feel they are to solving the problem. So one of them was the BC problem. So I'll read it out here. It goes, a stranger approached a museum curator and offered him an ancient bronze coin. The coin had an authentic appearance and was marked with the date 544 BC. The curator had happily made acquisitions from suspicious sources before, but this time he promptly called the police and had the stranger arrested. Why? So does anybody know the answer to this particular riddle? What's wrong with the date?
At the year 544 BC, they didn't know it was 544
BC. Exactly. So the reason that he knew it had to be a fake is that if you were living in 544 BC, that's either before Christ or before the Common Era, you didn't know when that was going. You didn't know you were living in 544 BC. They did not call 544 BC 544 BC in 544 BC. And that sentence alone will let you know why time travel stories are so hard to follow, because we lack the language for it. But that was the answer to this question. So they had this BC problem, and then she also used anagrams. She used jumbled up words, and you have to unjumble the words, to come to an English word. So she would have like a whole bunch of words, whole bunch of letters, and then you would unjumble them and be like, it's refrigerator. I get it, it's refrigerator. So those are the two tasks. And then what she did is she ran her subjects individually, and she asked them to rate how close they were to a solution at 10-second intervals. So I always find this a little amazing because I kind of read the room sometimes when we do this demo, and students kind of feel like 30 seconds is too often. Can you imagine having to check in every 10 seconds to indicate how close you feel you are to a solution? Seems pretty quick, but that was what she did, how close they were in 10-second intervals. And once again, she had 0 being cold, she had 10 being solved, just like us. And let's take a look at what happened with the BC problem. So here are her graphs for the BC problem. Here are the results for the BC problem. And this is the data for people that were correct. People that basically said, if you were living in the time of BC and minting coins, you didn't know it was BC, so you wouldn't have minted it 544 BC. These were people that got it incorrect. So these were people that said, well, maybe that metal wasn't invented in 544 BC. Maybe the curator saw this person's picture at the post office on the most wanted sign. So the height of each of these bars indicates how many subjects indicated feelings of warmth over here. So this is 0 over here. This is 10 over here. So the higher the bar, the more people indicated, in this example, 0 feelings of warmth, absolutely cold. And then, and this is the really key part, this were their ratings when they solved the problem. So when they said, I have the solution, that time was marked. And then she looked at what were their ratings 10 seconds before that time. And what were their ratings 20 seconds before. And what were their ratings 30 seconds before? So this rating here, a feeling of warmth, were how these subjects felt 30 seconds before they came, in this case, to the wrong solution. And then this was 40 seconds before. So what we can see here is that there seems to be a very distinct pattern that occurs in terms of feeling of knowing. So if you take a look at this incorrect solution, 40 seconds out and 30 seconds out, people are pretty sure, most people are sure, I'm not close to a solution. right? So 40 and 30 seconds before they were like, oh, right, it's he must have seen his picture at the post office. 40 and 30 seconds before they came up with the wrong answer, most of them were like, I have no idea what's going on. I'm rating it a 0. But notice what happened at 30 seconds. All of a sudden, more people started to feel like they were closer and closer to a solution. And then at 10 seconds, you can see that the highest bar shifts once again. So more and more people felt they were closer and closer to a solution until 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Oh, I get it. Yeah, they must have seen their photo at the post office. The metal was wrong. It was a wrong picture on the coin. That must have been the reason. And they ended up with the incorrect solution. So this gradual increase in feeling of knowing is a pattern that occurred when you got to the incorrect solution for this BC problem. Any questions on that? No? All right, so that's for the incorrect solution. Extremely interestingly, notice what happens for the correct solution. So subjects who ended up with the correct solution at 40 seconds out, 30 seconds out, 20 seconds out, or 10 seconds out from the solution, they all still felt they had no idea what the solution was. So even 10 seconds before they realized, oh, wait a second, it's BC. Even 10 seconds before, they were still thinking to themselves, I have no idea whatsoever. Nothing yet, oh, wait a second. Oh my gosh, it's BC. And then they get the solution. So this was the pattern that was found in the correct solutions. And even though these individuals were getting closer and closer and closer and closer to having a solution, they had no feelings of knowing. They had no feelings of getting closer to the solution until it actually occurred to them. And most kind of shockingly, the ones that did think they were getting closer to a solution were actually getting closer to an incorrect solution. So it's almost as if you have a mechanism that's going to lie to you. That, oh yeah, you're getting closer. Yeah, don't worry, you're doing all right. It's wrong, but you're getting closer to the solution. So it was a really kind of bizarre pattern that when you're right, you have no feelings that you're getting closer to the answer. But when you're wrong, you kind of increase in your feelings of getting closer to the answer. All right, so any questions about the BC problem? All right, well, let's take a look at anagrams. Mixed up letters. So the BC problem, let's backtrack just for a sec. The BC problem, this is an interesting problem because this is what's often known as an insight problem. This is what oftentimes leads to aha moments because this whole problem can only be solved in one step. There's only one realization to make, there's only one thing to realize, and that's the date and what it means. And then once you made that realization, it's solved. So you kind of have this aha phenomenon where you don't know what the answer is, and then all of a sudden, aha, eureka, I got it. It's the BC. Anagrams, on the other hand, these are jumbled up words. And when you're doing jumbled up words, if anybody's ever, played those games before, you know that there are certain rules, right? You know that there are certain steps that you can take to increase your chances to get close to the solution. So for example, has anybody ever done these word scrambles, word jumbles? What do you typically do when you do one of these scrambled words? What might be your first step?
I would just throw some letters together and see if you can find the word.
But which letters?
I look at first letters.
So you look for some first letters.
And vowels.
And vowels. So what do you do with vowels? Do you put them all together?
You pay attention to the vowels and put
You start-
each vowel in front of a consonant that I have.
Okay, so that's a step, right? You know in the English language, if you have E, A, O, U, that's probably not going to be together in the word, right? You're probably going to have some consonants between it. So step number one is you can take them and you can start putting some consonants between it, right? Step number two, if you see words that typically go together, you're going to place them together. So if you see a Q, you're going to be looking for that U, and you're going to put the Q and the U together. If you see an E and an R, you might think to yourself, oh, okay, this might be or it might be re, but they probably are going to go together. If you see an S, chances are it might go at the beginning, because there's a lot of words that begin with S. Chances are it might go at the end, because there's a lot of plural words that end in S. but you can kind of start putting things together. You can start moving it around in ways that English language works. So an anagram would seem to be this multi-step problem. You kind of start organizing the letters, you kind of start putting them together, and you should feel like you're getting closer to solution even before you can see, for example, the word refrigerator. Well, let's see what actually happened. In actuality, it's kind of the opposite. So once again, we have incorrect solutions over here. We got correct solutions over here. Once again, we have how do the subjects feel when they were 40 seconds away from solving it, 30 seconds, 20 seconds, 10 seconds away from solving it, and how do they feel when they actually solved it. And once again, we'll start off here with the incorrect solutions. And notice that 40 seconds out, 30 seconds out, 20 seconds out, 10 seconds out, they still thought they were nowhere near a solution. So even when they put their Q's and their U's together, even when they split up their vowels so they're not all together, and even when they put E's with R's and S's at the end, they still had no idea that they were at a solution until they finally came to a solution, and in this case, came to an incorrect solution. So the word is refrigerator, but they put, Jeffitator. It's like, oh yeah, it's a Jeffitator. Of course, I know that. But you can see here that a lot of people still did not know, I guess when time expired, that they were still pretty confident, like, I think it's a word, but not really a word. But that's a pattern for the incorrect solution. And the same thing for the correct solution. People that came up with the right word felt that they were nowhere near 40 seconds out, nowhere near 30, nowhere near 20 seconds out, nowhere near 10 seconds out. And then all of a sudden, it just kind of came to them, and they were like, oh my gosh, there it is. Refrigerator, I get it. And they had that solution. So that is Janet Metcalf's work back from 1986 on feelings of knowing. So any questions on her work? All right.